Taking a look at example 3. For a loan with 12% interest per annum, compounded monthly, to be cleared over 4 years, how many payments will reduce the debt to less than half the original loan? So, in finding our solution, we are going to use method 1, and method 1 would use the present value approach. There is also method 2 where we can use the future value approach, but for this specific example and moment, we are going to look at the present value approach. However, if you are interested in the future value approach, make sure to write in the comment section so that we work it out, and that will be interesting. Now, as before, let us identify each and every variable that is given to us. So firstly, we know that there is a loan that is given, and in the present value, let's call the value of the loan L. Since we are not given the loan, we are told also that it is meant to be cleared in 4 years' time. So our N is 4. Then the R, which is the interest rate per annum, is 0.12, that is to say 12%. And this is being compounded monthly. So our I is equal to 12. Right, so from equation 2 helps us to get the PMT, which is the equal installments that are to be made regularly. So PMT is given to be that. Now we are going to substitute. So we see that from our PMT, we've got 2 R's. So the first one is in the numerator of the first fraction, and the other one is in the numerator of the denominator in the second fraction. So we have substituted it in 2 places. Then we move on to the N. N is 4, and we only have one N, which is in the power in the denominator. Then we have the I, which is the compounding period. This is in 3 places. So in 2 places, it's in the denominator, and in 1 place in the power. So substituting for that, we would have it there. Then I'm sure we have substituted for every other thing. Oh yes, the PV. The PV is L, since we don't know the value of the loan. And of course, now the next thing would be to evaluate whatever we have that's within the pair of brackets. So in the first pair of brackets, we are going to have 1 over 100, because we know that 0.12 divided by 12, this is as good as saying 12 divided by 120. That would give us 1 over 100. Then we do the same thing in the denominator, in the fraction that we have there. So we have 1 plus 1 over 100. And of course, the power minus 4 times 12 would give us a minus 48. Right, so simplifying further, we are going to have the denominator in the denominator in the second fraction being 101 divided by 100. With that, we simplify that raised to the power minus 48, because there is no other way we can simplify this one further except to make it and evaluate it as a decimal. And if we do so, we have to make sure that we keep our values to either 4 or 5 decimal places. Now that would give us a 0.62026. So we've got 2 fractions here. And before we talk about the 2 fractions, let's evaluate the denominator in the second fraction. So 1 minus 0.6206, rather 0.6026. We are going to get 0.37974. Now we are going to multiply the numerator with the numerator, the denominator with the denominator, so that we get PMT of L over 37.974. Right, so that is going to be our PMT, or we express it in this manner. So that is the same as saying 1 divided by 37.974. That will give us a 0.0263 L. That will be the value of our PMT. Therefore, the value of the loan in NI periods or payments, since we don't know how long this would take, and that is what we are actually looking for, we are saying that the value of the loan in NI payments. So in order for us to get the value of the loan in NI payments, we are going to have it as L times 1 plus 0.12 divided by 12 raised to the power NI. And that is what would have given us the future value of the loan after NI payments. Now that from the previous step, we know that the 1 plus 0.12 divided by 12 would give us a 1.01 and raised to the power NI. So that would be the value of the loan after N1 payments, that is in the future state. Now, we know that the present value of the loan currently is L, so we would keep it to that. And also the present value of the NI payments to be made. So take note, the future payments of the loan were given by that step LV NI. But now we're saying that if we are going to make the payments, now we take it back into the present, we are going to have PVNI. And making use of the PV formula that we have in Formula 1, we are going to substitute for each and every variable that we have in that particular formula. So that would take us to have the PVNI of PMT times 12 divided by 0.12 times 1 minus 1 plus 0.12 divided by 12 raised to the power minus NI. Right, so with that then, we have substituted for each and every variable that we are given. And of course, evaluating what we have, we are going to substitute for the PMT because we have already obtained the PMT that we calculated earlier on. And that is the value that we have on the left-hand side of 0.0263L. We substitute it in place of PMT so that we have our present value NI, that is to say the present value after NI payments is going to be 0.0263L times the 100 that we obtained when we divide 12 by 0.12 times what we have in the second set of parentheses. So that will be 1 minus 1.01 raised to the power NI. Now with that, we see that the 0.0263 multiplied by 100 would give us a 2.63L times the 1 minus 1.01 raised to the power minus NI. That would be our PVNI. So now that we have the present value payments, so that is to say that the value of the payments that are going to be made in NI periods in its expressed as the present value and the PMT that we have, we can actually get the present value balance of the loan, because remember, we have the value of the loan after the NI period. We have calculated that, and we also have the present value of the NI payments that were made, including the interest. That is what we are going to say the value of the loan right now, because we are talking with regards to the loan right now. So the value of the loan minus the PVNI payments value that we have calculated, and that should be less than half of the L. So now that particular L, we bring that L into the present value. So that's why we are having 1.01 raised to the power minus NI, because we want to get that present value of the loan in the present. So that loan is going to have a certain value in the future, but we're bringing back into the present. So we want to express everything in the present sense. So as you would know, the value of $100 now will not be the same value after 10 years. What we have is the value of the $100 right now, but after 10 years, that's going to be a different amount. So that is the same logic that we're using. We are keeping everything in the present tense. So whatever the value would be in the future, we are bringing it back so that we get the present value of the loan. So we are getting the present value of half the balance of the loan in the present, what it would be worth in the present. That's why we are using the to the power minus ni. Now, we are going to substitute for each and every variable once again. So we know that our PVNI was obtained to be 2.63L times 1 minus 1.01 raised to the power ni. So that is what we calculated. All the other terms remain the same. So now we can expand the first bracket on the left-hand side. So when we expand it, we are going to have L minus 2.63L plus 2.63L 1.01 raised to the power ni. Take note, we were multiplying with the negative. So the first one becomes a negative and the second term becomes a positive. So that is what we would get. And of course, the next thing would be to group the like terms. We see that in the first two terms, these are L terms, and these can actually add up. So this is as good as saying 1 minus 2.63. That will give us a minus 1.63 L. The other term cannot be added because it has the power minus ni, which would complicate things. So let's keep it at what it is right now. So now we are going to move the terms with the power minus ni, which is the 2.63L times 1.01 to the power ni rather. Of course, the next step would be to divide throughout by L, since we have L in all three terms. So now when we divide throughout by L, we would end up having minus 1.63 plus 2.63 times 1.01 raised to the power ni, and that will be less than half of 1.01 to the power minus ni. Then of course the next thing would be to move all the terms with the power minus ni on one side. So I'm going to move the 2.63 times 1.01 raised to the power minus ni to the right hand side, so that we have a 0.5, because the 0.5 comes from the half. 0.5, 1.01 raised to the power minus ni minus 2.63 times 1.01 to the power minus ni. That would be that. And of course, as we group the like terms, we know that this is the same as saying 0.5 minus 2.63, since the terms are the same. That would give us a minus 1.63 on the left-hand side is less than minus 2.13 times the 1.01 raised to the power minus ni term. And we are going to interchange the positions of these values so that we have a positive 2.13 times 1.01 raised to the power minus ni, because we want our unknown to be on the left hand side. Then the other term becomes positive 1.63. Now we divide throughout by 2.13. When we do so, we're going to have 1.01 raised to the power minus ni being less than 0.76525. And introducing the natural log on both sides, we are going to have that. And of course, recalling from the properties and the laws of natural logarithms, we know that we can actually express that as minus ni multiplying the natural log of 1.01 is less than the natural log of 0.76525. Now we have our NI, so we can divide both sides by the natural log of 1.01. And since the NI is negative, let's divide throughout by the negative as well, so that we have NI being greater. So now as we divide with the negative, we know from inequalities, if we divide or multiply with the negative, the sign changes. That is to say, the direction of the sign changes. Therefore, we are going to have the natural log of 0.76525 divided by the natural log of 1.01. And simplifying further, we are going to have NI is greater than 26.8. And take note, NI is the period of payments. So this is not the time, but the period. Therefore, this is 27 payments, approximately 27 payments, because we cannot make 26 payments. What happens to the 0.8 payment? So we are going to have it as at least 27 payments. That would clear the balance. And remember to subscribe so that you don't miss out on any of our future uploads. Make sure to check out all the other playlists we have so far. They might be beneficial to you, especially if you are a mathematics, statistics, financial mathematics student. And of course, I'll leave you with the following task. Find a question and post it on the related topic. Remember once again, your questions, feedback are always welcome here. Subscribe, like, and share so that you don't miss out on any of our future uploads. Thank you for watching Numbers Simplified. Remember, God loves you.